The core loss of a single phase, these are the input output voltage mentioned. This is the frequency of transformer is measured from 230 side volt side by feeding the primary 30 volt side from a variable voltage, variable frequency source while keeping the secondary circuit open. The core loss is measured to be 1050 watt for this input, okay, and the core loss is again measured to be this for this input. The hysteresis and eddy current losses of the transformer for these are input are respective. These are the four options. Okay. So we have to find the hysteresis and eddy current losses. So this is the very well organized question on transformer. This type of problem you can see in GATE in each and every year. So we are going to solve this. So first we have to read the question carefully. So from the question we can write the given that 230 volt, okay, 50 hertz. These are the core loss. These are the what? Core loss. The core loss is the value 1050 watt. For solving this type of question, the approach that you should be follow is understand the what is the question asked and what is the given data. From the given data, you can easily find out the required outputs and answer as well. So another side 138 volt and how much 30 hertz 138 volt and 30 hertz, okay, this and these are the this is for core loss also, and the losses is 500 watt. I wrote these two lines for your better understanding, otherwise you can skip these lines and direct solve the problem, okay. So now the V1 means the primary voltage, we can write 30 volt, and the frequency F1 is the 50 hertz as per the question, okay. So the AD current, here I write the short form AD current loss, ECL, AD current loss, okay, is PE1. This is for primary side, okay, and the hysteresis loss means hysteresis current loss, or you can say hysteresis loss HL is PH1. All right, and now for the V2 means the secondary side voltage, the V2 is mentioned as 138 volt, and your F2 means the frequency at the secondary side is 30 hertz, okay. So the AD current loss ECL we can write PE2, okay, and the hysteresis loss HL is equal to PH2. This is very simple what I am writing here. Now we have to apply the formula of AD current loss. So the formula of AD current loss, as we know, PE is proportional to B M square F square, okay. This is for AD current loss, and for the hysteresis loss means PH is proportional to B M 1.6 F. Okay, this is for hysteresis loss. In some books also you can see this 1.6, there is x. Okay, so the typical value of x is 1.6, so I can direct write the 1.6 here. It is not an issue. Okay, so for the transformer induced EMF, we know the induced EMF of transformer equation is Vm is equal to 4.44 N phi m F. Okay, this is the EMF equation of transformer. EMF equation. Okay. That all right. Here now the 4 phi we can write phi as Bm into A. Okay, this is the formula. This is true when V by T is constant in this EMF equation. So the flux is constant here. Okay, phi is constant. So we can write the eddy current loss PE is proportional to V square. Okay, V square. And in other hand, the hysteresis loss pH is V 1.6, V to the power 1.6 divided by F to the power 0.6. Alright, so now we can put the formula here, PE2 by PE1. This is for eddy current, is V2 by V1 square. This problem is quite lengthy, but don't memorize this, just see how I am solving this. What is the approach for the, what is the method, what is the concept behind this question, and you can solve this question or this type of question easily. Just nothing, we just putting the values of this and getting this value, and the PE2 I can write 0.36 into what, PE1. This is my one equation, I can say. Okay, similarly what I am doing here, I just doing the same type for pH2 by pH1, and the formula as like V2 by V1 is square multiply with F1 by F2. Okay, to the power 1.6 0.6. All right, sorry, I did a mistake here. This is 1.6. This is this equation. Okay, so putting the value of those, we can write 138 divided by 230, which is primary voltage, is whole to the power 1.6 multiply with 50, which is primary frequency, divided by 30, which is secondary frequency, whole to the power 0.6, and the value of this 2 is like 0.6. So I can write PH2. Okay, yeah. And this PH1 is going this side, so it is become PH1. So this is the another equation. I can say it equation 2. All right, hope you understand up to this. Now, as the given data, what is the given? Yes, the hysteresis and eddy current losses of the transformer for this 230 volt and 50 hertz input. Okay, so here I'm doing nothing, just write the same, that the core loss CL is PE1 plus PH1 is equal to 1050 watt, as the question mentioned in the first. Okay, and the core loss for the second input voltage and frequency is PE2 plus PH2 is equal to 500 watt, as per the question mentioned. Okay, this is for first and this is for second. Okay, and now I'm writing the what value I get here, that is this value, what is this and this. Okay, this is for PE2 and this is for PH2, so I can write 0.36 PE1 plus 0.6 PH1 is equal to 500 watt. What I am doing here, just putting the values of PE2 and PH2. This is PH2 and the value is PE2. Okay, I'm doing the value in this equation and solving the equation number 3 and the equation we got here number 4. Alright, so solving these two equations, I can write directly the value of PH1 is 508 watt and the value of PE1 is what? 542 watt. Okay, so these are the hysteresis and eddy current losses for 230 volt 50 hertz. Okay, so the option is like this, option A, 508 watt and 542 watt. Okay,